Well, that came out pretty nice. Hope I put enough screws in there. Well, here I am, back in the shop again. One of the requests I've had from several subscribers is to share a little bit more of the thought process behind the design of the housing, the design of the assembly, when I make one of these machines. And so what I'm going to try to do is share a little bit of that right now. So I've spent quite a bit of time thinking about this. I've thought a lot about how long it's been since I've used a CAD program. It would definitely be easier to show some of this stuff on a 3D solid modeling program, but I've been through so many of those in my engineering career at various levels of proficiency. But the problem right now, especially since I've been retired, is I don't use them enough to maintain the proficiency, and it's kind of like starting over every time I do it. So anyway, this is where I am right now. I rethought the bearing support for the spindle. So this is the spindle that will drive the hob and locate the hob. It's going to be a 30 taper. It'll have a drawbar through the middle, and it's going to be supported in the center of the spindle by a stack of angular contact bearings. I think that's going to be just fine for what this has to do. So I'm going to put the drive gear is going to be overhung rather than have bearings on both sides. I think that's overkill. So I'm going to put a stack of 6 or 8 angular contact bearings right down the middle, mounted in a common bore. It ought to be really easy to get this machined correctly for that. It doesn't really take much to locate those. You just stack them up with some of the bearings oriented with the pressure angle that way, some of them oriented with the pressure angle that way. And when you clamp it all up, they come together just right. So those bearings are going to be mounted in a bearing retainer, a bearing locator, a sleeve basically, some O-rings, threaded nut on one end to clamp everything up, and then that'll go into a bore that is mounted to a heavy cover plate that covers part of the back part of the box. And so that'll be adjustable this way. There'll be some kind of clamp arrangement to clamp down on that and locate it and retain it. That'll give me the ability to have a little bit of adjustment on the engagement of these bevel gears, so that's good. There'll be a cover plate that comes in from the back, just mounts around with a group of cap screws for sealing. I'm sure it's going to require RTV to get it to seal. But the housing itself, so this is the top view of the housing. The spindle of the machine tool head is going this way. The axis of the hob is running this way. So this is the kind of plan view. This is the edge view down here, and this is the end view. The backbone is this 5/8 thick piece of steel here that's about 19 inches long and 8 inches wide. And that really forms the primary structural surface or structural member. But there are also these side rails that are that wide that run around 3 sides of that. In the back, there's a set of ways that'll be welded on standoffs like that. So this is kind of a section view. The ways will provide location, but this whole top surface, the ways here and the tops of these side rails all have to be machined to a flush condition. This part here needs to be oil tight. I'm going to run this about half full of oil to splash around and lubricate all the components, the bearings and so forth. So that's important that it be oil tight. There's going to be a flush cover that'll have to be welded into the in between these rails. I'm going to have to do a scarf weld around the three sides of that because it needs to be machined flush. And I mentioned the bearing support is attached to the cover that'll go over this, probably with a couple of dowel pins and a bolt pattern that will mount it and retain it and locate it. This end is going to be a bronze bushing that'll go on a standard bearing block from an 1¼ inch arbor set. That's going to be the outboard support, and that'll be adjustable in and out for different sorts of operations. But basically, that's going to be an oil lubricated bronze bushing. There's quite a bit of area there. Those things really do a pretty good job. I'll have to come up with a way of supplying oil to the bushing, which I haven't done yet. But basically, that's the setup. So I need to start cutting pieces of steel to go on here. I'm going to start by cutting this big piece and getting it set up. I'm going to have to do some pre-machining on the inside because I don't want to machine any of that surface after everything's been welded. So, and then cut the side pieces, cut these rails and so on, and I'll have to kind of lay them out and see what the best sequence of welding operations is. So I'm going to try to cut all the rough stock, lay it out on the bench, and we'll make a plan from there. Well, this may take a while. Well, flattening a piece of steel plate this way with light cuts and a fly cutter is tedious as all get out, but boy, the finish sure does look good. I'm helpless before a good surface finish. Slow, really slow, my God. Man, I gotta get a vertical bandsaw. I'd buy narrower stock, but the steel store's closed on the weekend. So you do what you gotta do. Well, this is the rough arrangement of the housing. At a piece of 5/8 steel plate that's going to be the backbone, and these pieces of 1/2 inch will be the structural sides. This right here is a wall that will help close this area off because that has to hold oil. So this is going to have to be welded continuously on at least one side, probably both sides, just to make it a little bit stronger, I guess. But anyway, and this is the basis for the ways that are going to mount the arbor support, the outboard arbor support. So that there'll be a gear here driving a bevel gear. There'll be another bevel gear mounted here. The shaft will go that way, and then there'll be a one-piece plate, probably 1/4 inch steel, that will seal the end of it, but still give access to the drawbar. Well, this is all pretty heavy welding, so I'm TIG welding at 200 amps, and it's a hot day, and dang, the torch gets hot after a while. So this is basically a break while the daggone torch cools off. Maybe I'll get a water-cooled torch with some of that fat YouTube cache that I'm not getting. So anyway, that's what the housing looks like at this stage. Still a lot of welding to do. Well, there it is. That's the weldment for the hobbing head for the Van Norman machine. It's about 96 degrees in my shop right now, even with ventilation running. It's a really hot day here. And the TIG torch kept overheating, and I had to stop and wait for it to cool off, and finally I just said screw that and got out the MIG machine and finished this off. It's so much faster. I'll do nice clean, well, I'm bragging now, but nice clean TIG welds in the wintertime when it's a little cooler in here. Those of you that have watched my videos before know that I'm really exaggerating my TIG ability. But anyway, this doesn't look too bad. Just doing a couple of roughing passes on this top surface on my Bridgeport-like machine. I'm going to use this milling cutter to clean up the top surface and then give it a final pass with a fly cutter to give it a really nice surface finish and a fairly precise level. Well, my wireless mic crapped out on me for this little clip here, and I just was commenting that I had to stop and take everything off the machine and weld in this cover plate that's actually being machined right now. So a bit of a backup and start again, and this is just about cleaning up, getting everything flat and level, and then we'll flip it over and machine it on the bottom face too to take any distortion out. This hopefully will be the final pass on the top surface. And then when I'm done with this, I'll flip it over and machine the bottom side parallel. Probably about the same way. So far, so good. Bring up the edges. I'm going to have to turn this over again at some point. I need a true edge that's aligned with the x-axis. So that'll give me a basis for clamping on the other side. Those colors. Yeah. Well, this is the weldment with most of the surface machining done. Now top and bottom are finished in parallel. These ways are straight and square with the axis and machined to size. So the next step will be to turn it over and take the vise off, mount this thing face down or top down on the table, and then I'll start doing the boring and drilling and tapping and stuff that happens on the bottom. Stay tuned. This is new. This is an Arex facing and boring head. I found it on eBay for a reasonable amount of money, and I need to be able to face on the mill. This is a really versatile tool. like every time I use a boring head, particularly a new one, I go through a real learning curve, but it always ends up with running it at higher speeds and lower downfeed rates. There's also a bit of an art in setting the cutting angle of the tool, but it's just one of those things I keep having to learn. Well, this is my first crack at facing with this Narex boring and facing head. So you have to kind of watch carefully to see the chips coming off the face of the part. But this is a really cool little machine. I should have had one of these before, I think. Would have saved me a lot of trouble. There, the feed kicked out. That's a little clutch pin. That's exactly what we want to have happen. Well, there's still some work to do on the housing, but it's at a stage now where it's actually kind of functional, and I've got enough parts that I can test run it, so I'm going to show you a sneak preview of that. There's still more work to do, and I'll document that in some future videos. Okay, this really is the first run, so I'm kind of curious to see how this goes. All ahead dead slow. Under power for the first time. That's not bad. I'm going to run the speed up just a little bit. Doesn't seem like it's binding anywhere. Let's see. A3. $250 RPM. This would be at the high end of a hobbing speed. I can hear it a little bit there, but that's not bad. I don't want to run it too long. I don't have any oil in the bearings. But woohoo! Well, so far so good.